In this lesson on position time graphs, you're going to learn how to construct a position time graph from data and also how to interpret a position time graph. So we're still talking about motion in one dimension, motion along a straight line. And we're going to define one direction as positive and the other as negative, as we did before. Here, we're going to use right as positive and left as negative. So imagine you've got a number line like this. Let's just put some markers on it like so. And we're defining right as positive. And instead of throwing a ball to my dog, I'm just going to be walking up and down the number line. So that's my situation. But now we're going to turn this vertically. So here it is vertical, and now as I walk along here, you can imagine the same thing happening in the vertical dimension. And that means we can use the horizontal direction for something else. We're going to use that for time. So imagine that as I move up and down here, I have a little marker that I'm using to mark where I am. It can be helpful to think of this like a seismograph. That's one of those devices that's used to measure earthquakes, where you've got something moving up and down in this direction. This would be, for example, the needle on a seismograph. In the example above, it's me moving up and down and tracing a little line as the paper moves that way underneath. And that's going to leave this tracing as I move up or down the paper, just like as the seismograph needle moves up and down. Okay, here's a further illustration. I've copied the little picture of me and the number line from above. As I move along here, if I graph this so that this is the position right, then as I move to 5 there, I've got to move to 5 here. So let's say that that's my 5. As I move to 10 here, I have to move to 10 there. Now, what I'm doing though, as I do that, is I'm leaving a little mark behind me. So if I start here at, we'll call that 0, and I move up to 5, let's say I move like this, at every moment I'm leaving drawing a little mark like the needle on the seismograph. So that might look something like this. If I'm moving at a constant speed, I might see something like that. Let's say then that I sit here at 5 for a little while. I'm stationary, but the paper's still spooling out underneath me. I'm still making marks. And so if I stay still, then this is just a horizontal line. Let's say after that I move back to the origin, then the line's going to come back down like this. Oh, I should have marked this as time, and we'll give that units of seconds. Okay, here's another illustration. This simulation is from PhET. I'll put the link in an annotation. First, we're going to watch what this guy does. Notice that he doesn't start at the origin. He starts at the 4 meter mark. He starts there and moves to the left with constant speed, and then he's going to get to about the -3 meter mark. He's going to stop there. He's going to hold on for a little while. Now he's going to move to the right with faster speed than before, but still constant. Then he turns around and moves to the left, but now he's picking up speed. Okay, let's watch that again with the position time graph. The position time graph is below. What you're going to see is this blue arrow represents the man. So it is 4-ish meters to the right, just like he's 4-ish meters to the right. And as he moves to the left, it's going to move down along here. Time, remember, keeps spooling out to the right. Let's watch that. Moving to the left with constant speed. Notice that when he gets to the 3 meter mark and he hangs on, he's got a horizontal line on the position time graph. Now he moves to the right with constant speed, and then he moves to the left with increasing speed. So a few things to notice here. First of all, when he was moving to the left, the graph was sloping down with a negative slope. When he was staying put, it was horizontal. When he was moving to the right, it was sloping up with positive slope. When he had constant speed, the graph was a straight line here and here. Remember, the second time when he was moving to the right, it was faster and the graph is steeper. And here when he was picking up speed, we see a curving graph. So you might just want to replay that one more time to make sure you've got all of that. Okay, now we're going to practice graphing position time data when given a table of values. So here you can see on the y-axis, I've got position in meters and defined as right of the origin. So all of these values are to the right of the origin, all of these values are to the left, and time is along the x-axis here. So you graph this just like any other table of values. So at time 0 seconds, our object starts at 4 meters to the right of the origin. At 2 seconds, it's still at 4 meters, and you continue like that. The only other thing that you need to know is that I'm going to tell you in this situation we're being given here, whenever position is changing, is doing so with constant velocity, meaning that we've got line segments joining each of the data points. There's no curves or anything like that. That isn't obvious here because you don't know what's going on, for example, between 0 and 2 seconds. But if I tell you that, you should be able to graph all of this. So pause the video now and graph that, and then compare to what I'll show you in a moment. Okay, so here's the graph, so you can check your answer, and I've also superimposed the picture from the simulation before, so we can just make sure that we understand what's happening here. So if this is describing the movement of that same person along the timeline, then they start at the 4 meter mark, 4 meters to the right of the origin, hang out there for a bit, and then move to the 6 meter mark over this timeline, over those 2 seconds, from 4 to 6 seconds, hang out there for a bit, then move more quickly, but with constant velocity, to the negative 8 meter mark, hang out there for a bit, now we're here on the graph, and then come back to the negative 2 meter mark. Okay, so that's what this situation could be illustrating. Let's take a look at one more position time graph. Here I've given you the graph, and let's make sure that we understand what it's telling us. Again, position in meters, right is defined as positive here on the y-axis and time on the x-axis. So notice that we start to the left of the origin by 6 meters, travel moving at a constant speed to the 8 meter mark, then hang out there until 12 seconds, and then at 12 seconds start moving leftwards with constant velocity until we reach the negative 2 meter mark at 20 seconds. A few things to notice here, a bit of a preview of what's to come. If we go from 6 meters to the left to 8 meters to the right of the origin, that's 14 meters, and if we've done so in this 7 seconds, so from 6 to 8 in 7 seconds, that's 14 meters in 7 seconds, or 2 meters per second, and we're moving to the right, and that's the average velocity over this time interval. So V average over that first time interval is 2 meters per second right. Here, if we're not moving, the average velocity in this time interval is just 0. And here we're going from the 8 meter mark to the negative 2 meter mark, that's 10 meters, and we're doing that in 8 seconds. 10 divided by 8 is 1.25. So V average is 1.25 meters per second, and in this case, it's to the left. Okay, so that is position time graphs.